Vector-based images. These are scalable images. Scalable vector graphics. SVG stands for scalable vector graphics. You zoom the image to any size, you will not notice any pixels breaking out. Whereas in the raster image, you cannot zoom the image beyond a limit. The pixels will start breaking out. The pixels will become visible. Okay. Then basics of digital images. Digital images are simple dots placed in horizontal and vertical directions. They are dots, nothing else. They are simple dots. Whereas we place some dots and notice some patterns. We call them images. We call the images. You just take a look at this. We place some dots. You place some dots close to each other and we change the color. We can change the color and place them in a grid, in a rectangular grid. Such dots, when placed together, when they are arranged close to each other, we begin to see some patterns and we call them images. Whereas for a digital image, it is nothing but a series of dots. Each dot is called a pixel. Each dot is called a pixel. We have rows and columns of images. Rows and columns. I don't think the dots are visible. Maybe we have to draw them and focus. Even focus. Barely visible on the other side. Okay. Rows and columns. Images are grids arranged in rows and columns. Each pixel can take any color it wishes. R, G, B. Red, green, and blue. This is the normal color space. For printing, we use CMYK color space. Cyan, magenta, yellow, and black. CMYK. Cyan, magenta, yellow, and black. CMYK color space. Okay. Each dot is called a pixel. What are they talking about? Pixels are arranged in rectangular grids, rows and columns. Then each pixel is a dot in an image. Each pixel is placed as a dot. Then for monitor display, there are two popular systems. One is the RGB system. RGB system, red, green, and blue system. RGB. Followed by alpha value. Alpha is called transparency. Alpha is transparency optionally. Then HSL, hue, saturation, lightness. Hue means you take a basic color, red, green, or blue, and then saturation, how dark the color should be, saturation, and lightness, how light the color should be. You can control hue, saturation, and lightness. This is another system. Okay. Then HSV, hue, saturation, values. HSV is another system used for monitor displays. Okay, there are three basic systems used for monitor displays. The most popular and the first one is RGB system, red, green, and blue system. RGB stands for red, green, and blue. Can you repeat? Red, green, and blue. Red, green, and blue. Then HSL system, hue, saturation, lightness. Can you repeat? Hue, saturation, lightness. Hue, saturation, lightness. Hue means the tint of a color. Any color, any basic color is called a hue. You can make it very dark, saturation. You can make it very light, lightness. Okay. HSL system depends upon the selection of a basic color and then making it darker or lighter. HSL, hue, saturation, lightness. Then HSV, hue, saturation, value system. Hue, saturation, and value system depends upon the hue, saturation, and nothing else. It does not depend upon lightness. It simply goes on to hue, saturation, value. Done. Then there is another system used for printing. We normally take black printouts in our printers, whereas there are some color printers which can make color copies. Hmm? We have created the cover for frozen book. We did not print it in the black printer. We printed it on a different printer. It was a color printer. Whereas the color system used in color printer cannot use RGB, cannot use the basic RGB system. RGB is suitable only for monitors. The printer uses another system called CMYK. Can you repeat? CMYK. Can you repeat once more? CMYK. What is the color system used for printers? CMYK. It's called cyan, magenta, yellow, and black. Cyan, magenta, yellow, and black. Can you repeat? Cyan, magenta, yellow, black. Once more. Cyan, magenta, yellow, black. Okay. These are the four colors. K stands for black in this system because we already used B for blue. RGB system. B is used for blue color. We cannot use the same letter for black again. Therefore, they have used the last letter instead of the first one. Black. Last letter is K. They have used K instead of B for black, denoting black. Okay. Cyan, magenta, yellow, and black. CMYK system. CMYK system. Cyan, magenta, yellow, black. Then transparency values. A color can be very dark or sometimes transparent. Sometimes transparent. That is, a part of the portion behind the color may be made visible. Transparency value. Okay. Transparency takes a value from 0 to 255. 0 means no transparency. Alpha value. We normally call it the alpha value. 0 means no transparency. Whereas 255 means total transparency. Anything behind the object will be visible. You just take this glass panel. You can, what is it? You get some resemblance of whatever image is available on the other side, whatever object is available on the other side. You can take some resemblance. You cannot see the object totally. Whereas you may fix a proper glass panel. It's a frosted glass panel. Whereas you fix a normal glass panel, you will see through. You will see everything on the other side. Whereas you place another type of glass panel, black or any color, which does not permit light to pass through. What will happen? You cannot see anything. Then the black panel, which does not permit any vision on the other side, is called alpha 0, 0 alpha value, non-transparent, non-transparent. Okay, then the panel which permit total transparency is called 255 alpha value, is 255 in alpha value, full transparency. Whereas our images may have any value from 0 to 255, semi-transparent. Any value which is not 0, not 255 is called semi-transparent. Okay, semi-transparent. Okay, there are three types of transparency. One is fully transparent, transparent. Alpha 0. Alpha 0 stands for full transparency. Full transparency. Full transparency. Alpha 255 stands for alpha 255 sorry 0, no transparency, and 255 stands for full transparency. I have given the wrong explanation. And anything between 0 and 255, anything other than 0 and 255, alpha greater than 0, less than, and less than 255, semi-transparency, Transparency. What is transparency? Can you say? The ability to look through. Normally, they use this term for government and public organizations. This organization remains committed to transparency, total transparency. It means they will not hide anything from the public. They will not have any secret operations, full transparency. Whereas in images, anything that allows the portion behind to be visible is called transparency. It can have values from 0 to 255. 0 stands for no transparency. 255 stands for full transparency. Whereas any value other than 0 and 255 stands for semi-transparency. Okay. Then spacing of pixels is measured by PPI. Pixels per inch. You take 1 inch of space. You take 1 inch of space and count the number of pixels available in that 1 inch. We call it PPI. Pixels per inch. Pixels per inch. This is applicable for monitors and other video devices. Video devices like projector and monitor use PPI as the unit. PPI. PPI stands for pixels per inch. Can you repeat? Pixels per inch. Once more, pixels per inch. Okay. Whereas for printing, we don't use pixels. We call them dots. We call them dots. Therefore, when you print any graphics or text, you can use the term DPI. DPI stands for dots per inch. DPI stands for dots per inch. Within 1 inch of space, how many dots can be placed? This is called DPI. Can you repeat? Dots per inch. Can you repeat? Dots per inch. DPI stands for dots per inch. Okay. Okay, ma. Then we have introduced you to some new terms. They are RGB, red, green, blue. Can you repeat? Red, green, blue. HSL, hue, saturation, lightness. Hue, saturation, lightness. Then HSV, hue, saturation, value. Then CMYK, cyan, magenta, yellow, black. Okay, then beyond this, we have come to alpha value, and beyond the alpha value, we have gone to PPI, pixels per inch. Pixels per inch. Then in printing terms, we call it DPI, dots per inch. Okay, these are the terms we have introduced today. We'll stop theory with this. We'll go on to practical and then anything.